Cool. All right. Two more modules, 13 and 14. 13 is kind of short in compared to 14. Cool. All right. Okay. So, endpoint security overview. Various network devices are required to protect the network perimeter from the outside. You could have various devices like IPSs, authentication servers, firewalls, and so on. Since attacks, or many of them, do originate inside the network, you have to protect the inside as though it's also from the outside. The two main elements that have to be thought about when protecting the internal network is the endpoints and the infrastructure. Historically, the employee endpoints were company-issued computers. But the reality is that's not the endpoint anymore. Workers can bring their own devices, their own home laptops. There's IoT devices everywhere. They don't necessarily require a human on the other side. There's a lot of devices that have traditionally not existed as endpoints that now we have to think about when we think about our network and how we're going to secure it. Besides using traditional things like antiviruses and IPSs, now every new device brings its own challenge. While we have some things that we can do network-wide, like installing software on all the endpoints, enabling filtering, having block lists, and preventing our data from getting out, we can only do so much. Now, there are things like the advanced malware protection that listen in on the network on end devices, and when something's acting funny, they react. There's email security appliances that do more than just content for spam. Web security appliances who are looking at the traffic coming in and out of our web servers. And network admission control. Our endpoints, no matter what they are, whether a laptop or a desktop or a IoT device, they're all susceptible to data theft. So we have to think about, how do we secure the data? How do we make sure that anything that is on our network is protected? Because it's never a matter of if, it is always a matter of when. Network access control allows only authorized and compliant systems to access the network. They have various capabilities, from like profiling and visibility that recognizes users and their devices before anything can happen. There's guest network access, security posture checking, which basically runs the computer through like an agent or an agentless check to see, does this device have all updates? Does this device have some form of anti-malware? Connecting to things like a Radius server to help verify this is who they say they are. All just ways that network access control can be implemented to begin securing our networks. The IEEE made the 802.1x standard that defines port-based access control and authentication protocol to restrict unauthorized workstations from connecting to a LAN. There are a couple of terms that go with this standard, like the supplicant, which is just another word for the client who requests access to the LAN. The authenticator, which could be a switch, a network switch, if it's not connected to something like a radius server. And then you have the authentication server, which again could be something like radius. So in this way, when a device wants to join the network, it has to verify the user and who it is. And that process will go through the switch to an authenticator server to verify their identity, give proper access, and then let them through. This is the whole process that 802.1x takes to go from a user wants to connect to enabling that user to connect. Of course, it all happens in a blink of an eye, but sometimes you need to configure a switch to override 802.1x. This is definitely one of those, it depends on the situation. I wouldn't say this is the rule. You could use the authentication port control interface to basically do it yourself, along with the syntaxes here below on what you can do. If you want to enable 802.1x, and it is a good idea to enable it, you would make a new model. You would give it a name, give it a radius server that it'll connect to, and say you want to use .1x. You globally enable it if you want it across all interfaces, or just to be turned on. You can set it to automatic or whatever setting you need. And you set which interface will be the authentication. Where will those requests go? Because you don't want them going out on every port. You want a specific port to handle that. Because the last thing you want is to enable something like this and then allow any attacker to see the authentication traffic and cause mayhem for you. You want that to go on a separate network, preferably an air-gapped. Chapter 14 focuses on layer 2, which, by the way, there is a threat to every single layer of the OSI model. I have seen this question come up in interviews where they ask to describe a threat and a solution to a threat at every level or at every OSI layer. This will just focus on layer 2. So with layer 2, it can be considered one of the weakest in the OSI model, security-wise speaking. Here are some layer 2 attacks that we'll be talking about. There are Cisco solutions to some of those problems that, again, we'll talk about as we go through this. If you're using Cisco or not, the main advice is the same. Use secure variants of protocols like SSH, SCP, SSL. Consider using out of band management. That way it is harder for an attacker to see the management network and not be able to manipulate it and get control. Use a dedicated management VLAN where nothing but management traffic lives. And using access control filters, ACLs, to get rid of any unwanted access. A layer 2 switch uses a MAC address table in order to make any forwarding decisions. It doesn't care about the protocol that's carrying data. It just cares where it needs to make a forwarding decision. Which way does a packet need to go? Here is a table of a switch who doesn't yet know the address of the 4 computers connected to it. As data comes in and out from these computers, from these end devices, it begins to learn, oh, on port 1, I have this device with this MAC address. So now anytime I see traffic that's destined for this specific MAC address, I know where it's going. If a destination MAC address is unicast, the switch will look for a match between the destination MAC address of the frame and an entry in the MAC address table. If the destination MAC address is in the table, it'll forward the frame out through a specific port. If the address is not on the table, it will forward the frame to all ports except the incoming port. As switches receive frames from different devices, it'll keep adding to its address. So whenever it sees traffic for a specific MAC address, then it knows where to go. And it does, and next time it goes much faster. All MAC address tables have a fixed size. So it is totally possible for a switch to run out of memory in which to store MAC addresses. What attackers do, because they know this, what attackers do is they use tools to flood the table so that the switch no longer knows where to send data. At that point, a switch could become a hub where it forwards traffic everywhere, which again is to the attacker's advantage. And by doing that, it allows the attacker to see all traffic coming in and out, which could be the whole point of the attacker, so that they can intercept a specific traffic of a computer or device that they've been after. Port security would be the way to fight against this, where it only allows a specific number of MAC addresses to be learned on a specific port. All switch ports should be secured before the switch is deployed for production use. How a port is secured will depend always on its function. A very simple way is just disable any unused port on a switch. Port security limits the number of MAC addresses that will be learned in one port. So as soon as it sees 2 or more, it will prevent that from getting into the table. To prevent that flooding, to prevent the switch from being overran. The way to do all this is with switch port security. By default, all layer 2 switches or layer 2 switch ports are set to dynamic auto. You can set the maximum number of MAC addresses with switch port security maximum. The switch can be configured to learn about MAC addresses in secure ways, either manually by specifying what MAC address is allowed, by dynamically learning, where the source MAC address is remembered. When the switch is rebooted, it'll have to relearn that a new MAC address. Or dynamic learned sticky, where no matter if the switch is restarted, it'll still remember what MAC address is supposed to be connected to what switch port. Port security aging can be used to set a time for static or dynamic addresses on a port. It could either be absolute, where the secure addresses on a port are deleted after a specified time, or inactivity, when the port is deleted only if they are inactive for a certain amount of time. You can use aging to remove secure MAC addresses on a secure port without manually deleting the existence of a secure MAC address. So it kind of does it automated for you. If the MAC address of a device that is attached to the port differs from the list of secure addresses, then you have a port violation. By default, the port enters the error disabled state. And of course, you can choose what you want it to do, whether you could choose to protect, to restrict, or just simply shut down. In which case, nothing can be connected to it, and that's the end. This table shows you the comparisons of what actions a layer 2 switch can take. Again, it can either protect, where it discards traffic. It won't send a syslog message. It won't increase violation counter and won't shut down the port. Where shutdown does everything. Not only will it discard any traffic, it will record it to syslog. It'll increase a violation counter and also prevent that port from being used at all. When port security violation is in shutdown, the port is physically shut down and no traffic will be sent or received. It's like it's completely disconnected. You can do show port security to see the settings. Show port security interface will give you a specific interface's status. If you want to verify that a MAC address is sticking in the configuration, you can use show run. And to display all secure MAC addresses that are manually configured or dynamically learned on all switch interfaces, use the show port security address command. The MAC address notification feature will send an SNMP trap to a network management station whenever a new MAC address is added or an old address is deleted from the forwarding tables. This is great to keep track of what's happening on the network. You have a place of login. In this chapter, you have a packet tracer to do some port security. VLANs, moving on. It is totally possible to spoof a packet and jump through VLANs. STP is the tool that can do that for you, where you can craft a packet and have it be with multiple VLANs, so that as it jumps from one VLAN to the next, it strips that layer and jumps to the VLAN that you really want it to go to. If you want to disable this, where STP can't do it anymore, here are some steps. You'd have to disable auto trunking. You would disable any unused ports and put them in an unused VLAN. Manually enable the trunk link. Disable auto trunking. And set the native LAN to anything other than one, because that is the native LAN. So when an attacker tries to get into a network, they aim for the things that are most common. There is such a thing as a private VLAN. Provides layer 2 isolation between ports with the same broadcast domain. The three types that exist of PVLANs are promiscuous, isolated, and community. This example here shows you the three at work together. Shows you what ports can interconnect. The security provided by a PVLAN can be bypassed by using the router as a proxy. The second figure is an example of an attack. To mitigate this kind of attack, you can make an ACL that will deny traffic with a source and destination IP address that belongs to the same subnet. Some applications require that no traffic be forwarded at layer 2 between ports on the same switch, so that one neighbor does not see the traffic generated by another. In such scenarios, the use of PVLAN Edge feature ensures that there's no exchange of unicast, broadcast, or multicast traffic between PVLAN Edge ports on a switch. This feature is called the protected port. You can enable it by going into the switch port protected interface configuration mode command. You can configure this on a physical interface or an Ether channel group. If you are enabling for a port channel, it's enabled for all ports in that channel group. The PVLAN Edge is a feature that has only local significance to the switch. There's no isolation between two protected ports located on different switches. So this is a switch thing, a per switch. For DHCP, we have two main attacks, starvation and spoofing. Starvation is the goal of basically denial of servicing a DHCP server. DHCP spoofing occurs when a rogue DHCP server is connected to the network and provides false IP configuration parameters to legitimate clients. It can provide misleading information like the wrong default gateway, wrong DNS server, and IP addresses. DHCP starvation is easy to mitigate with port security. DHCP spoofing, on the other hand, does require more protection. DHCP spoofing can be mitigated on trusted ports. It helps mitigate against DHCP starvation attacks by rate limiting the number of discovery messages that an untrusted port can receive. When it's enabled, DHCP snooping is enabled on an interface or VLAN. A switch will receive a packet on an untrusted port, compare it with the information held in a binding table, and deny any packets containing any specific information. So you can make the switch to be smart and prevent packets from even reaching beyond the network. Here's a 4-step process in implementing DHCP snooping to prevent this type of attack on your network. Use IP DHCP snooping, enable trust on those specific interfaces, put a limit rate. If you wanted to enable it on a VLAN, you can as well. In this idea, this scenario, we have a trusted port and an untrusted port. We see which will be allowed to send information, send DHCP information, and which one will not. ARP is an old protocol that we still use in IPv4 networks. The easiest attacks with ARP is sending ARP packets to modify the tables on endpoint devices so that rather than talking to the right device, they're talking to the wrong. Cisco has the dynamic ARP inspection, DAI, which will look at ARP packets and determine whether this packet is legitimate and can go through or should be blocked because an attack is occurring. The guidelines that Cisco has is to enable DHCP snooping globally, enable snooping on selected VLANs, enable DAI, and configure trusted interfaces for both DHCP snooping, since it will compare the DHCP snooping information with ARP inspection. So it'll look at that list, at the DHCP list, and go, are you legitimate? If so, okay, then we trust you. In the previous topology, we had S1 connecting 2 users in VLAN 10. DAI would be configured to mitigate against ARP spoofing and ARP poisoning. DHCP snooping is enabled because DAI requires snooping binding table in order to operate. DHCP snooping and ARP inspection are both enabled in VLAN 10. The uplink port to the router is trusted, so it's configured as a trusted port. Then it can check the destination and source MACs and match it also with IP addresses. ARP inspection validate is a global config command used to configure DAI to drop any ARP packets where IP addresses are invalid. Of course, it is possible for an attacker to change their MAC address to spoof it to something else. Switches will examine MAC addresses and determine where it needs to go. To prevent spoofing for both MAC or IP addresses, there is the IP source guard security feature. IPSG looks not just at ARP, but at every packet. It also requires DHCP snooping to be enabled. So if you are thinking of overall protection for your network, then IPSG is the better way to go. Here's an example network with IP source guard enabled on the interfaces. The last protocol that we'll look at is spanning tree. It's a loop prevention network protocol that allows redundancy while creating a loop-free layer 2 topology. So whenever one trunk is down, it'll find another way to get the information out. With STP, layer 2 loops can form, causing broadcast, multicast, and unknown unicast frames to loop endlessly on the network. This is an easy way to bring down the entire network in a short amount of time. When the loop occurs, the MAC address table on a switch will constantly change with the updates from the broadcast frames, resulting in MAC address in the MAC database becoming unstable. That just has the effect of the switch using a lot of CPU power and making it unable to forward frames. So it slows down the network because it's trying to handle the large volume. Spanning tree algorithm designates a single switch as the root bridge and uses it as the reference point for everything else. In this example, switch 1 is chosen by election. All switches that participate in spanning tree protocol will exchange BDPU frames to determine which switch has the lowest ID on the network. The switch with the lowest automatically becomes the root bridge for the spanning tree algorithm math. When spanning tree has determined which paths are most desirable relative to the switch, it'll assign port rows to all the participating switches. So the rows of alternate and root then become set. Every spanning tree instance will have a switch designated as its root bridge. The root bridge will again serve as that reference point when doing math. Every 2 seconds, a BPDU frame will go out until a root is chosen. The path information is determined by summing up the individual port costs along the path from the destination to the root bridge. Each destination is actually a switch port. The default port costs are defined by the speed at which the port will operate. You can configure port costs to an interface, entering a spanning tree cost value. It can be anything from 1 to 200 million. When an admin wants a specific switch to be a root bridge, the bridge priority value must be adjusted to ensure it is lower than all other values on the network. There is a packet tracer. Well, you will get to do this. To mitigate attacks by attacking or spoofing, the root bridge and changing the topology of the network. We have, for example, where an attacker can make their host appear as the root bridge and capture all traffic and basically run the network. There are some methods that can be enabled. There's the port fast, BPDU guard, root guard, and loop guard. Port fast can be enabled on an interface using spanning tree port fast interface configuration command. You can do the show running config to see when it's enabled. BDPU guard can be enabled on a port just by using BDPU guard enable. You should always enable BDPU guard on all fast port or port fast enabled ports. Root guard is best deployed on ports that connect to switches that should not be the root bridge. That way, if a root guard enabled port receives BDPUs that are superior to those than the current root bridge is sending, that port is moved to a root inconsistent state. It's otherwise the listening state, and no traffic data is forwarded across that port. A layer 2 loop is usually created when a spanning tree protocol port in a redundant topology stops receiving BDPUs and erroneously transitions to the forwarding state. STP loop guard provides additional protection against these loops. If BDPUs are not received on a non-designated loop guard enabled port, the port will transition to loop inconsistent blocking state instead of listening, learning, forwarding. Loop guard should be enabled on all non-root guard ports. And you can enable it globally. These are just some ways that are already built into Cisco devices that you can prevent these attacks from causing mayhem on your network. You have a lab and 2 packet tracers up ahead that'll help you do this rather than just hearing me talk about it. Which you know is always my preferred. Because that skill, what do they call it? The skills test is definitely not just a regurgitation of information. It's much more than that. It's using these commands together to solve the problem at hand. As usual, any questions, feel free to throw them on Discord. Your grades should be up to date, but let me know if you